Hey guys, hope you had a good weekend. You need to be on page 98 of your workbook, page 98. We're on lesson 19. We're still doing multiplication and division with fractions. And we already know that multiplication and division of fractions is related. And we also know that we have to remember if you're multiplying numbers, whether they're fractions or whole numbers, it doesn't matter what order that you multiply in. But if you're dividing, there's a big difference in dividing a number by 1/2 or dividing 1/2 by a number. So we have to really pay attention to that. On the warm-up on page 98, we're going to be working with the same exact two numbers each time. We're working with the whole number 3, and we're working with 1/10. So on the first one, it just asks us to evaluate, well, I guess I left the marker off that this weekend. Okay, it asks us to evaluate 3 times 1/10. Okay, so we said it really doesn't matter what order you multiply in. So if we go ahead and calculate this one out, we have 1/10 3 times, but we know we would put this over 1. And so then we would multiply straight across. 3 times 1 is 3. 1 times 10 is 10. So our answer on the first one is 3/10. Now, for the second one, I always tell y'all to just look for those quick cues to, so you can get your answer quickly and move on. And that'll really help you on standardized tests. Now, we just said before this lesson started that it doesn't matter what order you multiply in. So the next one gives us 1/10 times 3. We use the exact two numbers, and we said that it doesn't matter what order you multiply in, you're still going to get the same answer. So quick tip on that one, I should just be able to tell myself, all right, I just multiplied those two numbers and got 3/10, so I think this should be 3/10. And for now, until we get used to that, let's always double check our work. We know that we always place our whole number over 1. So, and then we would multiply straight across. 1 times 3 is 3, and 10 times 1 is 10. So we did, in fact, get the same answer. So the quick trick, it does fall into place. It doesn't matter what order we multiply in. But for the next one, we're still working with the same two numbers, but this time we're dividing. Now, let's do some reasoning before we get started. If I'm just looking at this 1/10 divided by 3, the first thing you always want to do is just check and see what your answer, what's a reasonable answer for you on this. I have 1/10 of something, so like I have just a tenth of a pan of macaroni and cheese, and that tenth of a pan we have to share or divide up between 3 whole people. So I know that there's no way anybody's going to get a whole pan. So I know that my answer is going to be less than 1. Okay? So I know my answer is going to be a fraction. So if I come out with anything that is over 1, I know that I did something wrong. And then let's just do what we know to do when we're dividing with a fraction. Our whole number always goes over 1. And when we're dividing fractions, we slide the first one over, we flip or get the reciprocal of the second, which would be 1/3, and then we multiply. So we have 1 times 1 is 1, 10 times 3 is 30, and that makes sense. We said our number was going to be less than 1. We knew it was going to be a fraction, and it makes sense that if I only have 1/10 of that pan of macaroni and cheese and I have to split it between 3 people, each would only get 1/30. And then the last one, we still are working with the exact same numbers. But unlike multiplying, where we said it doesn't matter what order you do it in, it makes a big difference when you're working with division. So let's think about this one. I have 3 wholes of something, and I'm going to take that and divide it into little bitty pieces in tenths. So that should tell me right there, I know that my number is going to be a whole number. It's going to be greater than 1. Actually, we know it's going to be greater than 3, don't we? Because if we have 3 and we're dividing it into little tenths, we know that we're going to have a number higher than 3. So then we work it out as we know to do with our problem here. We place the whole number over 1. We slide the first one on over. We flip or do the reciprocal of the second, which would be 10 over 1, and then we multiply. So we would have 3 times 10 is 30. 1 times 1 is 1, and we know that any number over 1 is simply itself. So our final answer is 30, and that definitely fits into what we said. We said that it was going to be greater than 1. We said that it was going to be greater than 3, so our theory of our reasoning was correct. We came out with 30. Okay, let's move on to page 99. Now, I know on page 99 it says you're going to be working as partners, but we know we can't do that, so we're all going to work them together. Okay, on page 99, it says that Diego's dad is making hamburgers for the picnic. There are 2 pounds of beef in the package. Each burger uses 1/4 pound. How many burgers can be made with the beef in the package? Now, just some simple reasoning, I know that it's going to be a whole number, because if I have 2 pounds and each one of them is only going to be 1/4 pound each, I know that I'm going to have a whole number of burgers that I can make. And the first thing it asks us to do is draw a diagram to represent the situation. Okay, so if I have my package of beef and I know that it's 2 pounds, so I would have 2 pounds here. And then I know that if each pound was being divided into fourths. So I would have 1, 2, 3, 1, 2, 3. So now each one is divided into fourths. So there's our diagram. And then question 2, write a division equation to represent the situation. Well, I have 2 pounds that was being divided into fourths. So then I know that I place my whole number over 1. I slide on over because I'm dividing. I flip or get the reciprocal of the second one, and then we multiply. So we have 2 times 4 is 8. 1 times 1 is 1, which is simply 8. So our division problem shows us that Diego's dad could make 8 burgers. And that's reasonable. We said that since we started with 2 pounds and we were dividing it up into fourths, we knew we were going to have a whole number answer, a whole number of burgers. And then once we get that, we can double check in our diagram. It was divided into fourths, and there were 1, 2, 3, 4, 5, 6, 7, 8 of them. So Diego's dad could make 8 burgers. Now, we've talked about there's a huge relationship between multiplication and division. So then it asks you to write a multiplication equation to represent the situation. Well, we have 1/4. How many times? Look at our diagram. We have 1/4 8 times. So then there's our multiplication situation, and we can work it on out to see if it fits what we're doing. Okay, we're multiplying, so we're not going to be flipping anything. We'll slide on over. And, oh, excuse me, we don't have to slide, do we? We've already got it written. Well, we've got to write it there anyway. All right, so we have 1/4. This is the same as 8 over 1. We just move that over. We don't flip because we're not multiplying. 1 times 8 is 8. 4 times 1 is 4. And we know it doesn't make a lot of sense to say 8/4, so we know anytime we have an improper fraction, we can change it to a whole number or mixed number by dividing top to bottom. 8 divided by 4. So 4 goes into 8 2 times. 2 times 4 is 8. We subtract and we get a 0 remainder. So 8 divided by 4, or 8/4, is 2. Now, how does that fit into our situation? Well, Diego's dad started with 2 pounds of hamburger meat. Okay, so we have used the same situation to diagram. We could write a division problem and a multiplication problem for the same situation. Okay, on page 100. Diego and Claire are going to share 1/4 pound of potato salad. How many pounds of potato salad will each person get? Now, the first thing, let's reason and see what we think is our answer going to be a whole number or a fraction. So they start out, all they have to start out with is 1/4 of a pound, and then they have to split it between 2 people. So if I reason that out, I know that my answer is going to be less than 1. There's no way that either one of them is going to get a whole pound of potato salad. Say, the first thing it says, let's draw a diagram to represent the situation. So here's our pan of potato salad. And they said that all they had to share was 1/4 of a pound. So this is all they have to share right here. And then they have to share that between 2 people. So now if I look at it like they were all there, we'll finish putting that in. They're not all there. But if they were all there, then each of them would get 1/8. Each of these little pieces would be 1/8. All right, and number 2, it says write a division equation to represent the situation. All right, we had a 1/4 of a pound, and we had to divide that 1/4 of a pound of that potato salad between 2 whole people. And we know that when we're dividing and it involves fractions, we place our whole number over a 1. We slide the first one over. We flip or get the reciprocal of the second, and we multiply. So 1 times 1 is 1. 4 times 2 is 8. I get 1/8, and we know that's reasonable. We knew it was going to be less than 1 because they only had 1/4 to start with. And in our diagram, we determined that each one would be 1/8. Number 3, it says write a multiplication problem to represent the situation. Well, we know that they're related. We know multiplication and division are related. So now we have to think, okay, we had 1/8 2 times because they were sharing it between 2 people. So this is all they had to work with. So they had 1/8 2 times. When we're multiplying fractions, we simply put the whole number over 1, keep the first fraction, keep the second fraction. We don't flip when we're multiplying. And then we multiply straight across. 1 times 2 is 2. 8 times 1 is 8. If we simplify 2/8, They're each divisible by 2. So 2 divided by 2 is 1. 8 divided by 2 is 4. And this definitely fits our situation because 1/4 is what they had to share to start with. 1/4 of the potato salad. All right, on page 101, it's saying working in partners, but we can't partner. So we're just going to do them all together. The directions say write a multiplication or division expression to represent the situation. And we know that we can do that because they are related. It says you can draw a diagram if it helps. You don't have to draw a diagram. So the first one, the distance from Han's house to Priya's house is 4/5 of a kilometer. Han walked 3/4 of the way already. How many kilometers has he walked? Well, let's always start first to think what's going to be a reasonable answer. If the distance between Han and Priya's house is only 4/5 of a kilometer, we know that there's no way it's going to be a whole number because it's not even a whole kilometer between the houses to start with. So we know our answer is going to be a fraction. It's going to be less than 1 kilometer. Okay, and this is where thinking about our English to Mathlish comes in. Han has walked 3/4 of the 4/5 kilometers between the two houses. And we know that in math, of is multiply. So he's walked 3/4 of 4/5. So he's walked 3/4 of 4/5. And we know how to multiply fractions. We multiply straight across. So we have 3 times 4 is 12. 4 times 5 is 20. And then we look to see, can we break that down? Can we simplify it any more? We know that they're both divisible by 2. So we have 12 divided by 2 is 6. 20 divided by 2 is 10. Now, we stop to look and see, okay, is this in simplest form? Again, they're both divisible by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. And then I stop and look. Is there any number that they can both be divided by and get a 0 remainder? And no, there's not. There's not any number that I can divide 3 and 5 with except a 1, and that wouldn't change the answer. So he has walked 3/5 of a kilometer. And that makes sense. We were dealing in fifths to start with, weren't we? So we know if he's walking in fifths that he has walked 3/5 of the way. Or of the kilometer, excuse me. All right, now on B, or number 2, excuse me, on number 2. Okay, on number 2, it says, Claire's science class will test water samples in class. If there is a total of 1/2 gallon of water and 10 groups, how much water will each group get if Claire's teacher passes out an equal amount to each group? Okay, now on this one, again, let's think about what's reasonable. All they have to start with is a 1/2 gallon. And that has to be split between 10 groups. So we know that no group's going to get a whole gallon. So we already know that a reasonable answer, it's going to have to be a fraction. It's going to be less than 1. So if we think about, we have 1/2 gallon that we're having to divide between 10 whole groups. So we have 10 over 1. We're dividing fractions. We know we slide the first one on over. We flip or do the reciprocal of the second, and then we multiply. 1 times 1 is 1. 2 times 10 is 20. So each group would get 1/20. That makes sense. I said it was going to be less than 1. I knew it was going to be a fraction. And I know that if I only started with a half and they're doing it by 10 groups, then yes, that's reasonable that each group will get 1/20. Number 3. A container with 3 kilograms of strawberries is 1/5 full. How many kilograms can the container hold? So let's go ahead and think about what's reasonable here. I know that if 1/5 of it, 1/5 of the container is 3 kilograms, how many kilograms can it hold? Well, if it's already 3 kilograms and it's just 1/5 full, I know that my number is going to be a whole number. I know it's going to be more than 3 kilograms. Now, on this one, it may help to draw, may help you to draw. So if I had a container, here's my container of strawberries, and we said it was 1/5 full, so we know it's divided in fifths. So 1, 2, 3, 4, 5, it's divided in fifths. This is all that was full. And in that 1/5, there are 3 kilograms. So there's going to be 3 kilograms in each one. So how many kilograms altogether? We would have 1/5 kilogram, or excuse me, we'd have 3 kilograms. We have 3 kilograms, and they're each in fifths, so we have 1/5, and each fifth is 3, so we would have, is that right? Is that going to give me a whole number? Let's think about that one. If I multiply straight across, I'm going to get 3/5, and I said that my answer was going to be whole. Okay, so I know that's not right. Okay, so if I have, each one is 3, and that 3 was a fifth. Now, let me think about that one. If I place this over 1 and I slide across and I flip or do the reciprocal, and then we multiply. So 3 times 5 is 15. 1 times 1 is 1, which we know is 15. Now, is that a reasonable answer? Yeah, I knew it was going to be greater than 1. So, and then I can look up here. I have 3, 6, 9, 12, 15. So each container can hold 15 kilograms. All right, on page 102. Again, we can't do partners, so we're just going to do them all together. Okay, it says, it takes Han 4 minutes to walk 1/3 kilometers. How many minutes will it take him to walk 1 kilometer? Okay, so we know, let's think about our reasonable answer. If it takes him 4 minutes to walk 1/3, I know that my answer is going to be a whole number. It's going to definitely take him more than 4 minutes if he wants to walk a whole kilometer. Okay, so if it took him 4 minutes, and that 4 minutes was only a third, so he's dividing by that 4 minutes is a third, we would place our whole number over 1. We would slide over, do the reciprocal, or flip the second, and multiply. And we would have 4 times 3 is 12. 1 times 1 is 1, which we know any whole number over 1 is itself. So it would take him 12 minutes. Is that a reasonable answer? Yeah. If it took him 4 minutes just to walk a third of it, then it would take him 3 times that to walk 1 whole one. So we come out, definitely reasonable answer. It would take him 12 minutes to walk a whole kilometer. Right, number 2. Claire's goal was to collect 4 kilometers of soil sample for her science project. She collected 2 2/3 times her goal. What was the amount of soil she collected? Okay, this is one where English to Mathlish can really save you some time. She had 4 kilograms, 2 2/3 times. So now we know when we're working with a mixed number, this one's a little bit different than we've been doing previously. They've all just been a unit fraction. But this one we have a mixed number. So we have to convert to there are 2 different ways we can do it. We can convert to an improper fraction. So we would have 4 over 1 here. We'll take that on over. And then we multiply diagonally, add the numerator. So we would have 3 times 2 is 6, plus 2 is 8. Oh, we were working in thirds. Okay, and then we would multiply straight across. 4 times 8 is 32. 1 times 3 is 3. And then we know that if we end up with an improper fraction as our answer, it's kind of hard to understand if you say, well, she collected 32 thirds. So let's take that, read top to bottom. 32 divided by 3. 3 goes into 3 one time. 1 times 3 is 3, and we subtract. 3 minus 3 is 0, and we have the number 2 that we can bring down. 3 won't go into 2. 0 times 3 is 0, and we subtract. So we get 10 whole ones with 2 left over, and we were dealing in thirds. So Claire collected 10 2/3 kilograms. Now, there is another way that you could look at this problem. If you think back when we did distributive property, we knew that she had collected 4 kilograms 2 2/3 times. Remember, in distributive property, it's just how it's distributed or spread out. This 4, the 4 is being multiplied times 2, and, remember, and English to Mathlish, and it's being multiplied, the 4 is being multiplied times the 2/3. So if you want to do it distributive property way, still going to come out with the same answer. So we have 4 times 2 is 8. And then on this side, we would have 4 over 1 times 2 over 3. So we would have 4 times 2 is 8. 1 times 3 is 3. And then we would add them together. So I have 8 and 8/3. Well, let's see. 8, but that doesn't make sense. So we would go to the side and do the math. 8 divided by 3. 3 goes into 8 2 times. 2 times 3 is 6, and we subtract and get 2. There's nothing else to bring down. Let me move that just a little bit. There's nothing else to bring down, and 3 won't go into 2, so this is 2 whole ones, and with a remainder of 2, and we were working in thirds. So we have 8 whole ones and 2 2/3. So 8 and 2 whole ones together is 10 whole ones and 2/3, and that's exactly what we got when we calculated when the other way, when we changed this to an improper fraction and then multiplied straight across. So it does not matter to me which way you do it, whether you do the first way or you choose the second way and do distributive property. You are still going to get the same answer. Claire collected 10 2/3 kilograms. Quit grumbling, Bailey. Okay, the next one, number 3. A container can hold half pound of strawberries is 3/5 of the way full. How many pounds of strawberries are in the container? Okay, so let's think about that for a minute. Is my answer going to be a number greater than 1, or is it going to be a fraction? A container can hold a half pound of strawberries, and it's 3/5 of the way full. How many pounds of strawberries are in the container? Okay, if I reason that out, I know that my number is going to be less than 1 because the whole container itself won't hold but a half a pound. So I know there's no way that I can have more than a half a pound. So I know my answer can't be more than 1. So I have 3/5 of a half container. I have 3/5 of half a container. And we know that in math, of is multiply. So 3 times 1 is 3. 5 times 2 is 10. Does it fit my criteria? Yes, I knew my answer couldn't be a whole 1. So 1 there are 3/10, not 1, there are 3/10 pounds of strawberries in the container. 3/5 of 1/2 container. 3/5 of 1/2. All right, at the bottom of page 102, it just gives us a little lesson summary. It says that we solved problems using fraction, multiplication, and division, and yes, we did. It says we looked at different situations and saw that we could use either to solve, and yes, we did that. We had some that we showed both in multiplication and division because we know they're related. We know that we can multiply in any order and it doesn't change the outcome, but dividing has a way different outcome if you're dividing. So always make sure you think, are you dividing? What are you dividing? The fraction or the whole part? All right, and then it says that it gave us a diagram. It had a diagram, and we'll just say we're dealing in macaroni and cheese. Gave us a diagram. It says we have like 2 pounds. We'll say we had 2 pounds of macaroni and cheese. Well, actually, they told you it's beef. All right, we got 2 pounds of beef. And then it says in our little diagram, it has each of the 2 pounds is divided into thirds. Okay, so each is divided into thirds. So we know that we have, and then if we wanted to write this as multiplication, we have 1/3, 1, 2, 3, 4, 5, 6 times. Now, could you have also written 1/3 times 6 this way? Yeah, because in multiplication, it doesn't matter what order. We had 6 of 1/3, or we have 1/3 6 times. You're going to get the same exact answer. So this would be over a 1. 1 times 6 is 6. 3 times 1 is 3. And 6 divided by 3 is 2, which is our 2 pounds. And if you wrote it this way, you would still get the same answer. 6 times 1 is 6. 1 times 3 is 3. And 6 divided by 3 is 2. So either way, you get the same answer. And if they asked you to also write it as a division problem, we have 2 pounds that was being divided into thirds. If we're dividing, we keep the first one. We flip or get the reciprocal of the second, and then we multiply. So 2 times 3 is 6. 1 times 1 is 1. And any number divided by 1 is itself. And that makes sense because we have 1, 2, 3, 4, 5, 6 1/3. All right, so that wraps up today's lesson, and I'll see you guys tomorrow. Bye.